Okay, so today we're starting Unit B. This is covering matter and chemical change. This is the third unit that we've actually dealt with in this course, but it's the second unit in the textbook. Let's get going. So again, like I just said, we're beginning our third unit, covers matter and chemical change. So basically it's a chemistry unit, you can just call it that. We're going to start today by discussing the difference between matter and chemicals. That'll go real quick. But the main focus of today are going to be these 2 points right here. We're going to talk about basic science lab safety. In other words, the safety tips that you need in order to be safe inside of a lab. And hopefully, of course, once things go back to normal, we will have some science labs that we can do, as well as a complete WHMIS explanation. Now, WHMIS is basically this picture program that allows you to read what the dangers are of different chemicals just by the logo that's on the label. We'll get into that in greater detail, of course, but let's get going. So to start this unit, we have to have an understanding of the difference between matter and chemicals. And it's just a very subtle difference. It's not super big, but matter is just anything that has mass and takes up space. Now, chemicals, however, are substances that can be used or produced in reactions that cause a change to atoms or molecules. So hopefully you remember from previous science classes that all matter is made up of atoms. And atoms, of course, can form big clusters called molecules, which are just several different types of atoms all connected together to form that molecule, right? So a pencil, for instance, that'd be a good example of just matter, right? There's many different things that make up this pencil, but it is made up of matter. Vinegar would be a good example of a chemical. Now, vinegar, of course, is also made of matter, but because it's something that can be used or produced in reactions, it is a good example of a chemical rather than just plain old matter. You won't find many people who would say a pencil is a chemical, right? You could say maybe the pencil lead inside could be thought of as a chemical, but even still, I'd prefer saying a pencil is just matter, right? It's not really a chemical. Chemical change. Now, some chemicals will react with one another. When a chemical reaction happens, new chemicals are created. That's really, really important. We'll get into chemical reactions later, of course, but a chemical reaction is just when chemicals react with each other and it forms something new. The atoms that make it up, so in other words, the individual elements that make up those things that went into that chemical reaction are still present. They just rearranged, okay? So the classic baking soda mixed with vinegar experiment, often used in elementary school volcano demos and all that. That illustrates a good example of a chemical reaction, right? So you just have vinegar, which the fancy name, the sciencey name of saying it is acetic acid, which is C2H4O2, so 2 carbons, 4 hydrogens, and 2 oxygens. You don't need to know that, don't worry. And baking soda, which is known in science as its fancy sciencey name, sodium bicarbonate, which is sodium, that's Na, hydrogen, carbon, and then 3 oxygens. Those 2 things, when mixed together, will react, that's what this arrow is all about, to form something called sodium acetate. I always like the formula for sodium acetate because it looks like it says nacho. Anyway, and then it also forms water, and it forms a gas known as carbon dioxide. That's a chemical reaction. There are many different kinds of chemical reactions we'll look at. This is just the first one. Again, we'll get into that later. The main focus for today is going to be on lab safety. Ooh, I just skipped ahead too far. Here we go. There it is, lab safety. So in this unit, we will hopefully have a few opportunities to perform experiments using laboratory chemicals. In order to do so, we absolutely must demonstrate a full understanding of safety procedures. It is super, super important, right? If we're dealing with a science lab, we have to make sure we are safe at all times. So the first thing we have to have a good understanding of is personal protective equipment, or in other words, PPE. And this whole coronavirus thing, you should be actually pretty familiar with that word because it's been thrown around quite a lot lately. But in any lab, you must always wear appropriate PPE, personal protective equipment. Typically, this will include, in pretty much every lab that we'll deal with, safety glasses, which are provided for you, gloves, which are also provided for you, a lab coat, again, we also provide it, but then long pants, which you're gonna have to bring on your own, and closed shoes, which you would also have to bring on your own. So in other words, if we are ever having a lab, and again, I'll tell you several days in advance that, yep, we have a lab coming up on a certain day, you will be expected to come dressed appropriately. You will have to have long pants and closed shoes. So in other words, no shorts and no sandals or anything like that. Also, if you have long hair, it should be tied back. That way you don't get your hair caught in any chemicals or worse yet, an open flame. So of course, those are some basic safety things to wear. Here we go. Now, even with all this personal protective equipment, accidents can still happen. It's important to know how to deal with accidents before they actually happen, though, right? That's a huge part of lab safety. You have to be able to be prepared for whatever could happen. So for any chemicals we'll deal with in Science 9, spilling some on your skin will require you to thoroughly rinse with water. We're not going to deal with any chemicals that would require some other kind of chemical or some kind of ointment or something like that to solve your problem. Everything we'll deal with will wash off with water. But there will potentially be some labs, again, hopefully we can have them, but there will potentially be some labs where if you spill some of the chemical on your skin, it can cause a burn if you don't treat it ASAP. Now in the science labs, of course, sinks are available for you to rinse things with water, right? So if you spilt a little bit of chemical on your hand, immediately go to the sink and wash it off. Like that's the absolute first thing you need to do. If chemicals splash in your eyes, then you got a bit of a bigger problem, of course. That's why we wear those safety goggles. But again, somehow accidents can still theoretically happen. You will need to thoroughly rinse them in provided eye wash stations. They are located in the science labs. Hopefully we'll have a chance to have a look at them. They're actually kind of neat how they work. You just kind of like put your face right up against both like little nozzles, and then there's this button thing you push down. Again, hopefully nobody ever has to use that. I've never had to use one, to tell you the honest truth, but they are there if you need them. They'll rinse the absolute junk out of your eye. That's what I'll say. Now, there are also fire extinguishers in the lab in the event of a fire. It's pretty rare that we'll ever have to deal with that, but again, they're there if you need them. Now, a really important point that you need to have totally understood is this last point right here. Deal with an emergency first. If you get chemical inside your eyes or inside or on your skin or anything like that, that is your #1 priority to deal with. Do not worry about telling your teacher about it first. I know how backwards that sounds. You're always told, tell your teacher whenever something happens. No, in this case, if you get something on your skin, deal with that first. Believe me, as you guys are doing the lab, I will be supervising the whole time. If I see someone run towards the sink and start washing their hand, or if they head to the eye wash station and start rinsing out their eyes, I will know something just happened, right? So you don't have to worry about coming telling me, yeah, I got something on my eyes or I got something on my skin. I will know. I'll be able to help you from there. Deal with your emergency first. If you need, you can also have a group member come contact me, especially if it's something just kind of small. Oh, we spilled something. That's just fine. Okay, so deal with your emergency first. Your safety is the #1 priority, obviously. Anyway, this is making it sound like it's going to be like some huge big deal, like we're going to deal with something that'll like burn right through your arm. The stuff we deal with will be pretty minor. Again, the main focus is keep it out of your eyes, but that is why, of course, we wear the safety goggles, and we don't really deal with a huge amount of chemical to begin with. Anyway, so WHMIS, this is the big focus of today. This stands for Workplace Hazardous Materials Information System. It's a program that's been around for a while, but it's recently been updated. The system provides a plan for safely working with dangerous materials, both in a work setting and in a home setting. So in other words, after you finish school, at several jobs that you potentially could go on to, you might actually have to retake a WHMIS course, a course just like what we're doing right now, to learn about all these different labels to help protect you in a laboratory setting. It's very common having a WHMIS course. Now in Canada, employees working with chemicals are required by law to have demonstrated a full understanding of WHMIS, right? So in other words, if you are working some job that you deal with chemicals, you have to pass a WHMIS course before you're even allowed to enter that workforce. Now WHMIS initially was introduced in 1988, but it was recently updated in 2015 with modernized symbols and clearer rules. The old symbols are similar to the new ones. We're going to be learning the new ones in this lesson today, but the old ones, of course, are in your textbook because your textbooks are from before 2015. In order for you to participate in any labs, you will need to show a very strong understanding of WHMIS on an upcoming quiz. During online learning right now, you'll be watching this video, of course, January 4th, 2021. Your quiz will be Wednesday, January 6th, 2021. And again, what I expect on that quiz, as shocking as this sounds, is that you receive 80% or more. You'll be allowed to retake this quiz as many times as you need, but you need to show total proficiency in this before I allow you to participate in any labs. Okay, so again, you can retake this quiz as many times as you need, but you have to get 80% or more before you're allowed to participate in a lab. One thing I'll say about that quiz, it's not for marks, but I will be storing the result in PowerSchool just so it's on the record. Just say, hey, this is what you got on it. You did this quiz, it was there, it's done, good to go. Anyway. All right, so like I mentioned before, WHMIS is all about pictograms. It's about these little pictures that show up on labels on chemicals. There's 10 of them that we will need to know in this course. Three of them in particular are very similar to one another, so we won't really need to go super into detail. I'll get to that in a bit, but you will need to be able to recognize and understand all 10 of these. So if you ever are dealing with a chemical and you see any of these 10 symbols, you'll need to know what it means and how to deal with it safely so that you are not harmed in a lab. So for the first one, oh, and again, I should kind of back up. You probably already read this on Google Classroom. I am planning to put a little blurb. These notes are provided for you, so please make sure you're downloading them either onto your computer or onto your phone and having another read through them, because again, these are the updated symbols, not the ones that are in your textbook, and these are the ones that we will be using. Anyway, the first WHMIS symbol is the exploding bomb, right? So pretty clear symbol right here. It's something exploding. Clearly, that just means it's an explosion hazard, right? So the chemical may be able to the chemical may be able to react with itself, other things, or with heat to produce an explosion. Okay, read the label carefully to see what it would do on that case. For safety procedures, this is really the important thing. This is what I really care that you understand. Be careful what you mix it with. Okay, so in other words, if you see something that has this exploding bomb symbol on it, read the label carefully and say, hey, what can I mix it with? What can I not mix it with? Right? Also, don't puncture the container. Puncturing certain explosive things can cause them to explode. Do not heat the container. Do not store near a flame or flammable chemicals. You want to avoid that explosion. Next one, it's a flame on like a flat table kind of thing right here. That just means it's flammable. That's a pretty obvious one. So for some safety procedures, keep it away from heat, flame, or other flammable chemicals, and keep a fire extinguisher nearby just in case. Okay. Next one, this one's a little confusing. This one always throws people. It's like a circle that's on fire. I always saw this. I thought it was like some like Japanese cartoon character or something, like crazy hair or something like that. I don't know. That's how I always saw this, but it's a flame over a circle. What this actually means is it's something that is an oxidizing agent. That just basically means it can react with oxygen, which causes it to ignite. So it's very similar. I'll even go back. It's very similar to the exploding bomb and the flame. It's like if both of these were kind of put together, it can react with oxygen and may ignite. It could also contribute to combustion or may produce fumes that may ignite. These ones are kind of a wild card kind of thing. So for some safety procedures, again, what you really need to know about these oxidizing ones is that you need to keep it away from heat and flame and be really careful what you mix it with. Because sometimes if you mix the oxidizing agents with something, it can actually ignite in a fire right off the bat. Next one, gas cylinder. Like literally just looks like a compressed gas tube, right? Not a huge big deal. This just means the chemical is compressed and under high pressure. Not gonna lie, we will never deal with this in I don't even think anything in high school, but it's still useful to know. For some safety procedures, just keep it away from heat and flame. If you heated this up, it would expand and then potentially, burst the container. And of course, don't puncture the container either, because that could cause it to shoot pressurized gas out of it. Not a good thing. Next up, I love this symbol. I think it's like the most clear symbol other than the flammable one. It's like the most clear symbol you'll ever see, corrosion, right? It just looks like a little vial dripping some acid on either a rod or on a hand, and it's showing it's like corroding it. Basically, it means it's just going to eat away at whatever it touches, right? Usually something that's corrosive, like this symbol will show, is something that'll like destroy metal, potentially even wood, and then certainly skin. Right? So you want to keep it away from yourself. So for some safety procedures, be extremely careful not to spill it on anything. Not just you, of course, but also on the table or anything else, because it could be corrosive. Wear full PPE, all that stuff that I listed earlier on, especially gloves and lab coat and all that. And then carefully and completely clean up any spills as soon as possible. If you ever spilled something with this, you'll need to be very purposeful and careful on how you contain it. Basically, it just means, wear gloves and soak it up however you can with touching it as little as possible. Okay, be real careful. Next one, skull and crossbones. I think this one's also pretty straightforward, but it's very similar to some other ones you'll see in a minute. Skull and crossbones means it's poisonous if consumed or breathed, causing acute toxicity. So basically, if you breathed in the fumes or if you actually consumed it, so you ate or drank it, it would be poisonous. It would cause serious damage to you, could even kill you if you drank enough of it. So be really careful with these ones. For some safety procedures, wear full PPE. Do not breathe the fumes. Certain things you'd have to use a fume hood. Don't worry, we're not going to work with anything like that. In our courses, when we say don't breathe the fumes, we literally just mean don't lean over it and smell it, right? If you smell it, that could cause some serious issues with you too. But working at it at arm's length is totally fine. Wash your work site and your hands thoroughly after working with a chemical, even if PPE was worn and no spills occurred. So even if you didn't spill any of this chemical, if you were working on the counter and you didn't spill anything and you're all done your experiment, still wash your work site down. That means like with a wet cloth and all that, completely wash it down just in case, because you never know. Now, the next two are very similar to this. They're very slightly different. You don't have to worry about it too much, but just realize that these next ones kind of mean the same kind of thing. This one where it shows like a silhouette of a person and like an explosion happening inside them, that means a health hazard. So it may cause breathing issues, eye irritation, cancer, or reproductive harm, or other issues like that. Basically, a health hazard is just something that would have more long-term exposure issues, right? A very famous chemical that they used to use in insulation when building homes was something called asbestos. Now, if you work with asbestos too much, you can get some serious respiratory issues. That would be something that would qualify under a health hazard. We won't see this one too much, but for safety procedures, just be really careful and pay close attention to the warnings on the label. Wear full PPE, and a really important one, use in a well-ventilated room. So if possible, even use it in a fume hood where the fumes can be sucked away and out, or at least open some windows and stuff. Again, we won't really deal with anything like this, but it is still important to know. The exclamation mark also means something similar to these last two. It's less serious health effects through consumption, breathing, or direct contact. So these ones won't really kill you, but it still might be worthwhile just to be careful with it because it can cause some harm, right? So for safety procedure, of course, wear full PPE. That's pretty much a given. It's all these have that. Use in a well-ventilated room so you don't breathe any of the fumes in. Wash your work site and your hands thoroughly after working with a chemical, even if PPE was worn and no spills occurred. So even though this one isn't generally speaking fatal, hence no skull and crossbones, it still is a danger, hence the exclamation mark. So be careful when working with it. Next one, this is actually a new symbol that they introduced to 2015. This was not in the old WHMIS 1988 version. And I love this one because I think it also kind of really illustrates what it does. It shows like a dead tree and then like a dead fish. It's an environmental issue, right? So in other words, environmental ones, they may cause damage to local environments or ecosystems. So for safety procedures, wear full PPE because if it's dangerous to the environment, it's probably also dangerous to you. And then really important, dispose it according to the recommendations on the supplier label or the safety data sheet. Those are things that are provided with the chemical when you order it from a chemical company, right? Generally speaking, if this is on the label, it's not something you dump down the sink, right? You have to dispose it in a very special way. We won't deal with anything like this, but still important to know. Next one, biohazardous infectious materials. In Science 9, we don't deal with this, but when you're in Bio 20 or Bio 30, when you're in grade 11 or 12, you likely will be dealing with things like this. These are things that may cause infection or disease in living things, right? So for safety procedures, you need to wear full PPE and sterilize all working equipment afterwards using high heat or cleaning chemicals, and then follow proper disposal containers. So for example, of a biohazardous infectious materials, maybe you might be doing some sort of a dissection where you're dissecting a rat, for instance. You can't just take that and throw it in the garbage. There has to be special things you do with it. And you also have to make sure you're not getting any infection or any disease from working with that thing, right? Again, biohazards, we're not going to work on that in Science 9, but it is still important to know. The symbol is pretty like hardcore looking. It's like a bunch of, I don't even know what you call that. It looks like a bunch of C's that are all stitched together. That's a pretty unique one. It's kind of a hard one to remember, but again, you are expected to know it. All right, supplier label, I mentioned that just a second ago. On the chemicals container, there should be a label containing the safety information for that chemical. You must always be familiar with the hazards and precautions before working with a chemical. Okay, so in other words, you need to make sure you see what's on that supplier label and understand what you need to do if something bad happened. As you can see on this supplier label right here, it shows all the WHMIS symbols. So this one, you got like the toxic as well as the exclamation mark. So serious and not as serious. No, it kind of like contradicts itself, but hey, you never know what can happen. The key thing to read though is your instructions, right? So it's fatal if swallowed, whatever this chemical is, product K1. If you swallowed it, it would kill you. If you spill it on your skin, it's irritation. So just breaking this down further, the skull and crossbones part of this comes into swallowing this chemical. This less serious health effects, that's the exclamation mark, would come into the skin irritation. So like I said, even though it seems like it contradicts itself where it's serious and not serious, it's serious in one way, not as serious in another way. That's kind of where that's coming from there. It also has precautions on it, right? So wear protective gloves, wash hands thoroughly after handling it, of course, right? Because if it accidentally got on your hands and you went and ate something afterwards, you'd be in big trouble. Do not eat, drink, or smoke when using this product. Can't imagine why you'd be smoking in a lab, but you know what? It's on the label, so there it is. You got to read it anyway. And then store, locked up, blah, 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 right? Read the label, make sure you know what you're dealing with, and you're good to go. All right, so the WHMIS quiz, that'll be on Wednesday. In order to be allowed to participate in our labs, you must first pass with 80% or higher a short quiz regarding WHMIS information we've covered. This will include not only knowing the pictograms, so you'll have to know what they mean, but also knowing some safety procedures for each pictogram. As of right now, which is Sunday, January 3rd, I haven't put an online one together, but I do have my old one that I always gave in person. I'm going to adapt it so you'll be able to get it online. The quiz will be on Wednesday, January 6th. On Tuesday, January 5th, we're going to go over the textbook questions, which are these ones right here. And we'll also have a brief discussion about what we learned today. So there it is. Boom. In about a little over 20 minutes, we got it done. Again, the notes for this lesson are completely posted on Google Classroom. Have another look through them. You will need to know those WHMIS symbols, all 10 of them. Okay. The textbook questions, you need to get those done as well. There's, I guess, 6 different questions for you to do there. For question 6 in particular, I want you to use the updated WHMIS pictograms that we've covered, not the ones in the textbook. That's the 1988 ones. We don't use those ones anymore. Anyway, you know how to reach me. I am on Zoom this whole block. Best of luck.